etc. Let's look at means and variances. When we take a sample, we try to generalize findings from the sample to the population. Sample is not equal to the population. So what it means is sample can contain errors that is less than representative of the population. When we want to talk about the population from the sample, there are two aspects that becomes important. One is the sample mean, through which we try to talk about the population mean. And the second is the sample variance, through which we're going to talk about the population variance. The sample's representation about the population can influence by two main factors. One is the sample size. Smaller the sample, larger the population, the chances are the sample becomes less representative of the population. The second is when the population is heterogeneous, the sample becomes less representative of the population. If you go to a large population gathering, such as a concert or election meeting, where there are lots of people, there's heterogeneity in that population. So taking a sample from that population becomes less representative. On the other hand, if you go to a classroom where there are similar children of the similar ages, the chances of we taking a representative population from the classroom is much greater because there is more homogeneity in that population. So to overcome or to compensate for that heterogeneity, one way is to increase the sample size so that the sample becomes representative of the population. So often, the sample is less than representative of the population, not fully representative of the population. Therefore, when we talk about the population, we have to accommodate the error in relation to the estimation of the population from the sample. In relation to the mean, the sample mean can contain errors when we talk about the population. That deviation from the population mean is called the standard error of the sample mean about the population. So when we want to talk about the population mean from the sample mean, we have to talk with a confidence interval because we can't be exact about the population mean, but we can provide a confidence interval within which we can say that the population mean lies, but within a certain range of confidence. In business and social studies, the confidence interval that we usually take is 95% confidence level or 5% significance level. If we know the standard deviation of the population, we can use Z-score. If you don't know, we can use the T-score. But if the sample size is greater than 100, then the Z-score and the T-score values become same. And at 95% confidence level, for our two-tail testing, the value is 1.96. So when we express the population mean through the sample mean, we use the sample mean and we say plus or minus because that variation of our sample mean for the population mean can be less or more. So sample mean plus or minus, and we use the standard error as a fraction, standard error into 1.96 to express at 95% confidence level. So greater the sample size, larger the sample size, it becomes far more representative of the population. Smaller the sample size, it becomes less representative of the population, and the standard error of the sample mean increases. Because the error increases, the imprecision increases. When the sample size is smaller, when the sample size is larger, becomes more representative of the population, the precision of estimation of the population mean increases. That means the standard error of the sample mean decreases. The second aspect we look at is the variance. Through the sample variance, we estimate the population variance. When we express the population variance through the sample variance, we divide not by the sample size, but we divide by sample size minus 1. Variance is the variation or the deviation of each observation, each data point from the average, and that variation is measured as a squared so that the plus and the minus don't cancel out, and the variance is expressed as a result as a squared. But if we want to express as a standard deviation, then we take the square root. But taking the variance here, before we calculate the standard deviation, variance is calculated taking the squared values and the sum of all the squared values divided by sample size minus 1. We decrease the sample size by 1. So the question is, Why is it that we divide the sample variance n minus 1 rather than n, or the sample size? If we take a smaller sample, let's say the sample size is 10. Let's look at an example. Let's take different sample sizes. 10, 40, 80, and 100. And let's say the total sample variance for all those samples is 100. If we don't adjust the sample size, we divide the variance by the sample size, and then we get our results, which is shown in the third column, unadjusted sample variance. Now let's take one off from the sample size and adjust the sample size n minus 1, which is the fourth column. Now let's look at the adjusted sample variance by dividing the total sample variance by the adjusted sample size. Now that we have got unadjusted sample variance and adjusted sample variance, let's look at the difference between the two. For sample size of 10, that increase in variance from unadjusted to adjusted is 1.1. For sample size 40, it is 0.06. Sample size 80, it is 0.02. And sample size 100, it is 0.01. So we can see that the adjustment of the variance, or we increase the variance because we are now decreasing the denominator by minus 1. We are reducing the denominator by minus 1. But for smaller sample, that total increase is much greater. For example, sample size 10, it is 1.1. Sample size 100, it is 0.01 only. So by doing this, we are increasing the variance adjustment more for smaller sample size to represent the population variance compared to larger sample size where we make a small adjustment. This is because in practical terms, when we tend to take samples from the population, when we tend to take smaller samples, it's likely that we tend to take far more homogeneous samples and we tend to leave out the outliers or the extreme values in the population. But larger the sample size, the chances are we also will take the outliers into our sample. So that n minus 1 is also called the degree of freedom. Another way to think about this is think that someone has 7 hats to wear on 7 days. And then on the first day, the person has a choices of 7 choices to choose. And the number of choices keep decreasing, but on the 7th day, if there are only 7 hats to wear, 6 hats have been worn, only 1 hat is left. There's no freedom of choice there. And one got to select that last hat, whether like it or not. So when it comes to statistical analysis, one way to think about is when there's, for the last one, because there is no degree of freedom in the analysis, we omit that last item for greater precision. So we estimate from the sample the population, mean, and the variance. When we estimate, we have to accommodate for any errors or inaccuracies that the sample contains, and our equations represent or include those adjustments so that our calculations or estimations become far more representative of the population, so that when we talk from the sample about the population, our findings become far more representative of the population.